Okay, if I were asked to solve this equation, I'd look at it, and I'd still use the rational root theorem. It's the easiest thing for me to deal with. Actually, there's easier ways of doing it, but right now, rational root theorem is what we have at our disposal. You get a list. A list is an awful list, I know that. But I'm not gonna do that whole list. I'm gonna claim that I'd probably stumble on something pretty quickly. And what I'd stumble on, certainly I'd try 1 and -1. It wouldn't work. But I think I would stumble on, -2 rather quickly. Right? Like I try 1, -1. I try 2, -2, forth and so on and so on. And, I think I'd stop right there, and I think I would probably just simply divide at that point, right? So what I would do is I would divide the polynomial, and write this down for you, and I get x4 minus 44 x squared plus 16x plus 192. Well, let's see, that'd be x cubed, right? You get x cubed. I'm depressing the equation by doing this, by the way. And then what do I get? Plus 2x cubed. I'm sorry, this is x4. Sorry about that. Let me get my eraser out. Subtract. This is going to work out nicely. Don't worry about that. And if it doesn't work out nicely, something's horribly wrong with what I'm doing. Let's see, minus 2x squared. That would give me minus 2x cubed minus 4x squared. Subtract. Let's see, what do you get there? That would be minus 40x, right? That's minus 40 x squared minus 80 x. Let's see, you get 96 then, right? Plus 192. And what do you get there? Plus 96. All right? And kind of looking at that, it's a little bit easier than the 4th degree polynomial arithmetic-wise, but again, you're still in the same place, and you're writing down, the potential rational roots, plus or minus, and you'd get what? 1, 2, 3, 6, yada, yada, yada. And you're faced with testing them again. But the reason that I depressed the cubic was that it becomes easier for me to test these things out. But unfortunately, again, it is a little bit difficult. You're not going to find one until you hit 6. So when you evaluate this at 6, it's going to produce a 0. So we have 2 roots now. The 2 roots we found, minus 2 and 6. I would do a long division again. I get a quadratic. This quadratic, I would attempt to factor it. I can't factor it using my integers. So what I do is I resort to the quadratic formula. And the quadratic formula, you'll get this over here, right? But granted, I'm not saying this was easy to do, but I do get all 4 roots to the problem. All 4 roots I get, all right? Of course, going on to the Euler's method, to me, is much more difficult. All right, but it's in the proper form. I write down the A. This is the A. I write down the B. And I write down the C. I get a cubic by making a substitution. This is the substitution over here by doing those numbers. I still have to use the rational root theorem, but I'll be honest with you, the rational root theorem, this one's easier than what I just did before. By inspection, 4 would work. Then I get the other ones. I do it by long division in the quadratic form. I get these 2 over here. And then I write down the square roots of them. And by the way, they're nested roots. That requires work that we've done in the past, by the way. And that was a lot of work. There's no doubt about it. It was a lot of work to get through that. All right? We've done that in the past, by the way. And then writing down these combinations, and you're going to get the answers. What answer you're going to get? The same ones we got before. 6 minus 2, we got those. And the other ones we got, I want to remind you, these are long problems, aren't they? Minus 2 plus or minus 2 root 5. All right. Again, I put a little reminder down how to unnest a root. That's something we've done a long time ago. Hopefully you can jog your memory with respect to that. It often impresses people that you can actually do that. Some people believe you can't unnest a root, but you can unnest a root under certain conditions. And we've seen plenty of problems like that. All right, thank you. Before I go, though, I want to mention to you, my name is Ron Bannon. If you need to reach out to me, my email address is Bannon, B as in boy, the @ symbol, NNON.US. Thank you for paying attention.